10 seconds again. All right, so we were looking, this is on page 51. Good. We're looking at number 5. Because as far as conditional probabilities, when we have B given A, you're going to have, this is a very complex question. Now, when I looked through it really closely, I noticed that there's a first question that asks you, hey, do you like music and drama, or do you like athletics? And you were only asked that one question, right? Then it extended where it was, all right, so my second question is, do you like movies or karaoke? Right? Now, those were the only questions that I asked, but there's a intersection, crossing of people that like karaoke who had also answered back in the first question. They had already answered if they liked music and drama or athletics. Okay? So there's 2 different questions, and there's one other thing they saw here. Watch this. Students were then asked to choose among several entertaining activities, including movies and singing karaoke. They should have said, and others. Right? They should have said, and others. Several is never 2. Several is never 2. 2 is a pair or a couple. 3 is a few. 4 is something that we don't really use. 5 is like a handful. But several is more than 3. Several is multiple. It just doesn't mean 2. You wouldn't say I need several. And that might be a language thing where, you know, I had to look really close there. But this word several implies to me that there are other options. So if we were to make a two-way frequency table, we have greater overall interest, right? Music and drama, athletics. The total for all those was 80. For athletics, we know that 81 answered that they liked athletics. And then we have this other category, and that's what we're talking about today. We have category 1 and category 2. It's like 2 different questions. Category 2 was movies and karaoke. And what I put here are question marks because there's another activity, and probably another one of these. And we don't know anything about that data. So the reason why we were looking at this here is saying, wait a minute, 80 like music and drama, but within the context of it, I think it was, of the 40 that chose movies, 19 that chose music and drama, but down in here it said 31 that chose music and drama, and that didn't add up to our original 80 people that chose music and drama. The reason that it didn't is because there were some parts that were missing. Some parts that are missing that, you know, these don't add up to 80, they add up to 40. So, now watch how this is going to go. This is how it's going to go today. If I'm looking at the question down here, it says the probability that somebody chose music and drama given that they chose or liked movies. Okay, now watch what we're going to do with this. So the probability, I'm just going to write it here, of NB and N. What goes on top? Intersection. What goes on bottom? Given. Look at this chart. Tell your neighbor, what is the intersection of movies, music and drama, and movies? Excuse me. Music and drama and movies. Where do those intersect on this table? The intersection of movies and music and drama and movies is 19. 19. Let's see, what is the probability that somebody likes movies? What's our total number of occurrences that somebody likes movies? 40. Done. Okay. We're going to go into a little more depth because I was with a complex problem looking at this, but we'll do a few examples. But if we create our two-way frequency table, we could find our conditional probability like this. Like that. Okay. And I understand maybe you guys are like here after that example, because it's a hard example, right? So how about we do a really easy example, okay? We'll do an easy example. So let's do, go ahead and open your book to, let's open our book to page, it's the next one. I think it's 65. Open your workbooks to 65. All right, and we're gonna, the video is just gonna basically be us doing this example. What I'm having to do at the end is create a, I have it open up here. Whoa. So I am recording, so I need you guys to go behind. So Leland, go back that way, please. so you're not on the video. Thank you. All right. So if you go down the pages here. Let's see. Let's move it over. It's the first example in the next section. Can somebody suss that out? Find where the first example of the next section is. Let's see. We're talking two-way frequency tables. And it's example 1 as like a big chart. Here it is. Page 57. Excuse me. Not even close. 58 has some of these blank charts on it. So I want you to look at page 57. We're not going to do all these students. We're going to focus on the first 10. Okay. We're not going to do all of them. I want you just for this, for time and the number of problems I want to look at, we're going to just look at those 10. Okay, so the next page, doesn't it have the next page? Doesn't it have, yeah. So look on page 58. 58 has those tables. They're blank. Okay, so on the back you see the blank tables. Now I'm gonna draw mine right here. All right. So this is our category 1. Category 1 is going to be in this column. Now, category 1 is always the most general. An example of category 1 is what grade are you in, right? Category 1 would be, you can specify more than binary, but you can have gender, right? You can have, could be race. It could be different things that are more the general kind of basic things. It's not real specific. So looking here, we are going to have 10 students. We have information about the grade and these activities. So, well, which one of these, tell your neighbor, which one is the more general kind of question and answer to it? What is the more general of those two, activities or grade? Grade, you guys see? So watch, I'm going to put grade right here. So we're going to have 10th graders, 11th graders, 12th graders. How many different activities do we have? What letters do we have there? All right, if you're zoning out, bring it back. How many activities do we have? 3, right? So watch. I'm going to go in here, make 3. On the top, you'll also have to make, like within that top box, break that up. But you guys have that already done. And I'm going to call this activities. We're going to put some marginal frequencies out here. That's our totals from columns and rows. How many students total are we looking at? 10. 1, 2, 3, 4, 5, 6, 7, 8, 10. 10 altogether. Did you ask what we're doing? Okay. Gotcha. We're just going to look at the first 10 for simplicity. Now, I don't like activities just being FTD or TS. All the periods so far have made pretty original, ridiculous names for it. For instance, FT, period 2 said that was foot tag, which is you can only tag someone with your foot on their foot. I think that's kind of cool. So think of something. What are we going to say if FT is something? Tell your neighbor what's something funny. MPG 13.
Foos something.
That sounds like foot tag.
Foos.
Foos is German for foot.
Oh.
And it means yes. All right. Who knows they have a good thing for FT? What is FT? Leland. Freeze tag.
That was lame. Everybody agrees.
Freeze tag. Very good. All right, how about, looks like we have D. What's D? Margot. Detention. Watch, we're going to have everybody loves detention. All right, what's TS? Someone new. What's TS?
No.
Paloma? No. PG-13 plus? Okay. Terminal solitude. Dying alone. Temporary solitude.
Travis Scott would be better. kidding.
All right, we got our 3. We got our 3.
Terminal.
How many? Now here's how you're gonna ask the questions and put in the info.
Dark.
How many 10th graders? How many 10th graders like freeze tag? How many 10th graders? Freeze tag?
1, 2,
2, 3, 4. 4 10th graders like freeze tag. Okay. So the main work is I make my category 1 with the most general information. I look to see what fits into category 2. I label it, put them, and now we're asking one thing at a time. So it's not that hard to put the information in. How many 10th graders like detention? For real?
none of them.
None.
Oh, nice.
D, 10 and D? No. How many 10th graders like temporary solitude?
2.
1, 2. Everyone's confident they can count these if they
Sir?
have to, right? Like you can do each step. Okay, how many 11th graders like freeze tag?
0.
0. 11th graders like freeze tag? 0. How many 11th graders like detention?
1.
1. How many 11th graders like temporary solitude?
1.
Where's that? Oh yeah, that's the game. Okay, 1. How many 12th graders like freeze tag?
0.
0. How many 12th graders like detention?
2.
Weirdo. All right, and is there any more? Once you get all your sample space put in there, put zeros and everything else because there's no more potential to go there. Okay. I want you to give me your marginal frequencies here. Add up the columns. I want these marginal frequencies too. Add up the rows. Get your totals. All right, we're going to do a few examples. We'll make one up as a class, and then you have 3 problems for homework, kind of doing something similar to this, and you're going to make your own survey and ask everybody in the class. So that's what we're going to do the last like 20 minutes. Total? 3, 3, 2, 2, 6. All these marginal frequencies have to add up to 10. 6, 2, 2, 10. 4, 3, 3, 10. So you know you did it right. You didn't miscount. Okay? Is everyone okay so far? Right? Start to finish, we can do it. I think the hardest part so far has been how to like draw the table. So you'll get used to that. It's not bad. Okay, now here's the thing. I want you to tell me, what is the probability that you're a 10th grader? No, actually, I'm gonna switch. What is the probability that you like freeze tag, given that you are a 10th grader? So what do we need? What are the 2 components for a conditional probability? What goes on top? The intersection. What goes on the bottom? Very good. The given is always the second term. So look at your table. Tell me the intersection of freeze tag and 10. Where do I find that on here? Let's see. 10th graders. Freeze tag. The intersection of 10th graders and freeze tag. 4 occurrences. You could put 4 at 10, but you're going to end up flipping it. So let's do occurrences. That's not, that is acceptable within the standard. That's actually, you want to be able to get there to do occurrences. What is the probability? How many, essentially, if I'm picking a random student, I'm picking a random student to see what they like. What is the probability that this random student will be a 10th grader? How many 10th graders? 6 10th graders. The probability of being a 10th grader, if I'm looking at 10 kids, is 6 out of the 10 are probably going to be 10th graders. So that's 2/3. So that's 0.66, 66%, and that's all you have to do. The process before was much more cumbersome, but if we put our information in there like that, it's easier to find them. You agree it's a little easier than what we did before? All right. How about this? Probability that you like detention if you're a 12th grader. Again, what do you need? The intersection of those 2 events, and you need that 12th grader given probability. Find the number of occurrences. Check with your neighbor. You're like, hey, how come this got so much easier? because the table organizes it for you. You don't have to deduce as much as steps. All right, double check your neighbor. Blue. All right. Quick, right? Ethan. Yeah, you have to go out that door. You got to go out that door. All right, guys. What is the intersection of detention and 12th graders? 12th graders, detention, two occurrences. 2 out of how many 12th graders? So what is the chance that a 12th grader likes detention as their activity? 100%. It'd be 1.0. Let's see if this makes sense. Given that they're a 12th grader, here's my 12th graders. What's the probability they like detention? It's all of them. 2 out of the 2 like detention. What is wrong with class of 2020? Just kidding. I love class of 2020. Say hand up, Etienne.
Is the context of the first that out of the 6 10th graders there are, 66% of them like these passages for
Correct. Given that you're a 10th grader, what's the chance of you liking freeze tag? 4 out of 6 students. Remember, we're picking a random student. If I had all these students with names in a hat, I would have to separate them out and get just the 10th graders in the hat. And I'd say, what's the chance of picking a freeze tag person? 4 out of the 6 will like it, so it's 66%. Thumbs up, sideways, down? Okay. Okay. Okay, let's do one more. I'm glad to see the thumbs up for a second here. That's good. All right, this one's going to be a little tricky. You guys ready for a trickier one? Slightly?
Yes, sir.
Like that. Like that. What is the probability that you, let's see, that you like the complement of detention given that you're in 11th grade? This one's a little trickier because we have to find the intersection. First, I got to think about, well, what does the complement mean? Tell your neighbor what you think the complement is going to entail. We have 3 choices. What's going to be included in the complement of activities? The complement of detention is?
Terminal. So it's terminal.
Postmodern. All right, I think this is good. Did some people need to have that reminded? Right? So if our potential solutions are freeze tag, detention, and temporary solitude, the complement of detention is going to be which options? The other 2, right? If the answer set has all 3, right, that's everything. But detention would just be by itself in the set. We'd say, what's the complement of it? It's everything else that isn't us.
Oh, come on, Ethan.
I'm sorry, I almost hit you in the face. I didn't do that. Sorry. Hazmat. Can't be in me. All right. What is the probability? What is the probability of the given? It's your 11th grade. 2. 2 of the 10, but we don't have to put the 10, of course. Just 2 occurrences of my students. All right. Now, what is the, let's see, the complement of D? Tell your neighbor what you think. What do you think? This is going to help us remember something special here, something important. You want to say it? Say it for all of us?
Me and Jack said the complement of it was 7.
Good. Now remember, go back to the other problem. We had that you like freeze tag, given that you're a 10th grader, we still looked at freeze tag and looked at the total number of kids that liked freeze tag, right? And that's actually a weird example because it does fit within 10th grader as well. If I looked here, the 12th graders that liked detention, right? We didn't just say it was that liked detention. No, that's not right. Wait a minute. Why am I turned around? What did another group say? I am a little turned around. I got distracted by my rant on the video there. Did another group? So 7, we're going to take 4, we're going to take 3, add them together, because here's the deal. The chance of just a student liking the complement of D is 7 out of the 10. 70% chance that like somebody is just a student that likes it. Now, when we put in the ratio though, it cuts it and it says, well, really we're just looking at the 11th graders. But now I look at this and this isn't going to work. This doesn't work at all. 7 over 2 is more than 100% chance. That means you're like destined. It's not possible.
I thought it was, yeah. I thought it was one because there's one 11th
Of them. Yes. Within 11th graders, how many are not detention? Just one of them.
One.
So we look here. Does this make sense that the chance that you're 11th grader, if you like something other than detention, is 0.5, 50%? That makes sense within the context. So I think given the complement kind of messed us up a little bit. That's okay. We're going to make one up right now. We're going to make one up. And then we are going to, yeah.
Before you erase,
Yes.
can we do
That's all I'm doing
what
here.
we do with the cards, where for the given for the 11th graders, can you put a line across the array for the 11th graders in the
You wanted the complement of 11th graders?
No. So if you wanted like all parts on the cards, right? You would do lines for all the parts and everything. So for here, you could do the lines for all the 11th graders, and you could say, looking at just that,
I see.
which one of those is a complement?
Good. Given that you're 11th grader, what's the probability that you, that's easier to see it. Yeah, what's the probability that you're the complement of detention? 1. Okay. So how about when we do the example together right now? I'll do one using that method and it'll help others. So I think that's really good. Jim, thanks for bringing that up. All right. So do we have any 11th graders in here? Are we all 9th and 10th? Yeah, I'm a senior. I'm in college. I'm in 21st grade. That's my grade level. All right. Use the other box, use the other table, and we are going to make our own class example. First, we got to figure out what is our main category going to be. Should we do just 9th and 10th graders? That's easy?
Yes.
9? Okay. Now, look at this. And what kind of categories should we look at? Should we look at music? Should we look at what you do on the weekend? Should we do sports you like to watch? What's another category we could do? Weekend. What do we do on the weekend? Weekend fun. All right, so we have sleep. What else do you do on the weekend? Keep it PG-13, please. Sleepovers is going to be in sleep, because eventually you sleep. Yes?
Well, I run during the weekend, so I
Okay. Exercise?
exercise.
Okay. Exercise. I
Hang out
need
with
2 more.
Eat.
All right, so go out. Okay, eat. And then we'll say go out with friends. Go with friends.
Exercise.
There could be infinite numbers, right? You're doing the temporary solitude? You need to just go out? Hey, it's fine. If you can go out by yourself, you... Gotcha. It's like you don't get to do that, so you don't want to be on that. Okay. All right, go out. Go out can be pretty broad. Let's say go out with friends, go with family, go out by yourself, temporary solitude. All right. We have. Let's do this one together, guys. All right. We have how many in here? We got 30 people present. So raise your hand if you're a ninth grader, please. Ninth grader. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 ninth graders. I put that on here. Okay. So, you know, we have 30 in here, so I know there's 16 10th graders. Yeah. So I got some marginal totals out there. All right, guys. If you're a ninth grader and on the weekend you could only vote for one thing. One thing. Otherwise, it's not a universal, it's not universally fair. All right. One thing, decide what you're going to vote for. Ninth graders who like to sleep on the weekend, raise your hands. 1, 2, 3, 4, 5. All right, exercise. If you exercise on the weekend, that's what you do. Okay, 1. No, you listen.
Leland, you're not.
You're a 10th grader, huh?
Oh, 10th graders. Oh, okay, sorry.
All right, did you guys? You shouldn't have been listening. Actually, I meant ninth graders.
Oh, okay.
All right, is everyone that voted the 5 sleepers? You're all ninth graders.
Yes.
Yeah. All right, ninth graders who like exercise, raise your hand. I already got 1. Ninth graders who like to eat on the weekend, raise your hand. You voted for it. 1. All y'all, rest of you fasting. That's great. Ninth graders who like to go out. 1, 2, 3, 4, 5. Does that add up to our 14? No. Who didn't vote? That's ninth graders.
Jack, did you vote?
Ethan, which one of these do you like best? You like to eat? Perfect. Any other ninth graders didn't vote? It's no big deal. Just let me know. There's still one more. Maybe I didn't see your hand. So what I'm going to do, I know, I counted her not being here. I'm going to change it to 13. So you're out if you didn't. No worries. Yeah. 10th graders who sleep on the weekend. 10th graders. 1, 2, 3, 4.
I'm sorry.
Oh, yes, I will. Get to sleep. 10th graders who like exercise. 1, 2, 3, 4. Good. 10th graders who like to eat. 1. You can only vote for 1? Only 1.
Yeah, we fasted.
What?
We fasted.
Yeah, everyone's fasting. All right, 10th graders who like to go out on the weekend generally do. 1, 2, 3, 4, 5, 6, 7. Do all these add up to 16? Yes. Wait. Who voted twice? This is becoming 6.
Come on, Leland.
All right, give me these marginal frequencies. I didn't think it was Leland, but I'm just taking it.
Mr. P.
Hey.
I have to go, I guess.
Oh, man. All right.
I didn't know I was this early.
All right, check out Edmodo. Check out Edmodo. All right, you can. Excited about that. All right, we're back recording. Perfect. What are these totals? 10, 5, 3, 11. Perfect. All right. Now we have 29 total. Those both add to 29. Yep. So I'd like for you to find the probability that you like to go out, given that you're a ninth grader. You like to go out, given that you're a ninth grader. So we're at the given, at the intersection. Oh, that's why. That's why the last problem was a little bit skewed. Because the intersection is hard to see with 2 different events. We'll do that next. We'll do that next, okay?
Oh, right, it's 13, not 14.
What was that?
Yeah. Where's that from?
I don't know.
I don't
I
know.
didn't know.
It's North London. We'll all do accents.
No, it's my name.
It's my thing. All right, how many occurrences of the intersection of go out and ninth graders? 5. How about the probability that you are a ninth grader? How many occurrences? 13. Who has a decimal for me? Don't forget, I need those. We do it. 3, it's 39.38. Yes, Santa?
Ooh, I like that.
What in the world?
Look how quick they are. Did you already forget how slow it was before? Like, what else did we ever do? We're going to use two-way frequency tables as our method to organize information. I just think it really helps. Again,
Can I point out something?
please.
So, go is G-O, which is go out, but it's also just go, the beginning part of go out, and that works. Go can represent go out because it's the beginning of go out, but go can also represent go out because it's G and then the O. And this is a moment where we can appreciate that.
Yeah. Thank you for that spatial recognition. All right, how about this? I'm going to give you two more. Let's go. How about the probability that you, I'm going to change it around, that you're a 10th grader if you like to eat. It's different, right? You have an answer ready? You can. You got to go on the stage in 3, please.
16.
All right. Yeah, just like this row sometimes gets some people. Find the intersection of eat and 10th. Eat and 10th. How many? 1. What is the probability that you, how many occurrences do we have that you like to eat?
3.
Let's see if that makes sense. Let's see. The probability you're a 10th grader, given that you like to eat, so it's looking here, the probability that you're a 10th grader is 1 out of the 3 that like to eat. So that looks like we got through this pretty quick. Well, I said round, so we're going to keep it to the hundredths. Better. Thumbs up for this. It's good, right? All right. I'm glad. I like how it fit, because sometimes if we struggle with it a little bit, then you get another model to use it with. It's helpful. All right, this one's going to be the last one. It's going to be complex. And then you still have about 15 minutes to do your own. You're going to make your own and start surveying, asking each other. Okay? You got 3 problems for homework other than that survey option. Okay, so let's do the probability that you, here we go, that you sleep union
What?
or E given that you're a 9th grader. This is just like there's 2 options. This is the same as when we have the complement of D in that last problem.
Wait a minute.
Give me a sec.
That's a good question.
That is a little bit more than 1 pound.
7/13? What was the answer?
25.
7/13.
Because
Yeah. Okay. The first thing is probably the hardest to find. The intersection of sleeping, eating, and 9th graders. 9th graders? So since this is the last one, I'll draw on it. Like that. That's all my 9th graders. Now, where does it intersect with sleeping and eating? Union is talking about the total of them. So how many should I have on the top? 5. Raise your hand if you got 7 for that. Then that is very good. You should feel good about that. That was the trickiest I could throw your way. Really, that's as hard as we can get as far as conditions, other than having compound here. Okay, we can do that if you guys want. You'll have plenty to do the rest of the class, so we're gonna leave it. What is the probability that you're a 9th grader? 13 people are 9th graders. 13 out of the 29. 13, and that is equal to 0.48. 49. 0.4.
25.
Oh, sorry.
5.
All right, give me a thumbs up, sideways, down for this. Okay, excellent. Like the smiles too. The main thing here is you got to decide what your category is in general. You got to figure out how many categories you're doing here. And I said I wanted at least, I put on a motto, I think it's at least 3 categories and 3 category 2s at least. Okay? So, or, you know what, I think I said 2 of category 1. So you could do 9th and 10th graders again. You could do 9th and 10th graders again, but these categories too, if you're doing music, I want you to do at least 3 different options. And you're not going to the survey and like say, what's your favorite music? That's not helpful. You have to give a list of options, okay? Otherwise, you're going to have like 20 different categories because everyone might like different music. So make up like 3 or 4 categories and then ask specifically about them. All right, let me get to display.